Hi, I'm Professor Kelly, and this is a lecture on scope for CSCI 3-Way, Programming Language Design. Learning goals for this lecture are to be able to define scope, environment, identifier, attribute, and binding, to distinguish between dynamic and static scope, and to determine which type of scope a language has, static, dynamic, or relevant, that is to say, no scope. Let's start with the definitions. An identifier is the name of an entity in a program, such as a variable or function. The environment is all the identifiers available in a given part of the program. Scope is the range over which an environment is accessible. Attribute is information about an identifier, such as the variable's type. Binding is the association between an identifier and an entity and its attributes. For example, let's consider the following pseudocode in a Python-like language. Let's call this language Gorgon for the sake of giving it some sort of name. It doesn't necessarily behave like Python. In this example, we're creating a variable called example, which has the value global. There are two functions, inner, which prints example, and outer, which sets example to the value local and then calls inner. When we call inner, what do we expect to happen? Well, one possibility is we might just get an error. Variable example is undefined because there is no example inside the inner function. But in most programming languages, there is a way to use the example that we have outside of the function. Another possibility is inner, quite without complaint, will print global. But what happens if we call outer? Well, one possibility is that will also print global, that setting example to local will have no effect on printing example inside of inner. The other possibility is that it will have an effect, that setting example to local will cause inner to print local. What will happen depends on the type of scoping. In static, also known as lexical scoping, the binding of an identifier to an entity is determined by the location of the identifier in the source code. Static scoping is used by most modern imperative languages, and static scoping has nothing to do with whether a language has static typing or static method binding. These are independent design decisions for a language. A language could have static scoping, but dynamic typing and dynamic method binding. Going back to the previous example, when this code is first run, first we create a global environment in which we have the identifiers inner, outer, and example. When outer gets called, we have a new environment in which we have the variable example, and it has a value local. This is a separate and distinct copy of example from the one in the global scope. When inner is called inside of the outer function, we have a new scope. And now the question is, when we go to print example, do we go to the global scope or outer scope? In a statically scoped language, we go to the global scope and we'll print global. In a dynamically scoped language, however, the binding of an identifier to an entity is determined by the location of the function in the call stack at runtime. Dynamic scoping is used by some especially older languages. It has nothing to do with whether a language has dynamic typing or dynamic method binding. A language could have dynamic scope, but static typing and static method binding. Consider the previous example. When this code is first run, we'll create a global scope with inner, outer, and example. When outer is called, example gets a new separate copy with the value local. When inner is called, it's actually going to go back to outer's copy of local. And the reason it does this is because inner was called by outer. Inner goes what called me, what was the last thing on the call stack, and by going one step up in the call stack, it borrows all the variables inside of outer. So, how should scoping be structured? Should it be structured based on how things are nested in the code, or should it be structured based on how things are nested in the call stack? This is the fundamental question of whether to use dynamic scoping or static scoping. There's a third possibility, and that's your language doesn't have a scope. Scope is irrelevant if the language does not have variables or if all the variables are global. Some declarative languages don't really have variables, such as Haskell and Prolog, and some simple imperative languages treat all variables as global. Here's an example of a language where all variables are treated as global and what happens. We have the same example as before with function inner, function outer, and example equals global. The first thing that happens when this code is run is inner, outer, and example are identifiers added to the global scope, but everything is in the global scope. So when we call inner, we get global, but when we call outer, we get local. And that's because outer will change change the example variable to the value local. At first glance, this might look a little bit like dynamic scoping because before, with static scoping, when we called outer, we would get global, and with dynamic scoping, when we called outer, we would get local. However, unlike a dynamically scoped language, if we call inner again, we're going to still get local because the value of example was changed in the global scope. All right, to sum up, we wanted to learn to define scope, environment, identifier, attribute, and binding. An identifier is the name of an entity in a program. The environment is the available identifiers in a particular part of the program. The scope is the range of an identifier. Attribute is the information associated with an identifier, such as type. Binding is the identifier attribute association. To distinguish between dynamic and static scope, static scoping is when you use location in the code to determine which version of a variable to use. Dynamic scoping, on the other hand, is when you use location in the call stack at runtime to determine which version of a variable or identifier to use. Finally, if we want to determine which type of scope a language has, static, dynamic, or irrelevant, that is to say, it has no scope, well, you could do worse than using this pseudocode that you saw earlier in these slides. For statically scoped languages, we call outer and inner, we would get global printed out twice. And this is because outer setting the variable to local has no effect. In a dynamically scoped language, when we do call outer and then inner, we'll get local the first time because when inner is called inside of outer, inner uses outer's version of the variable. But when inner is called directly by the main program, it will print global. Conversely, in a language that does not have scoping, when we call outer and then inner, we'll get local, which is to say, outer modifies the variable's value to local, and then when we call inner, regardless of where we call it, it'll produce local. And that's it. That is scoping.